This is Pure 2, Chapter 9.2. So last lesson, we look at differentiating sin x and cos x. Today, we're going to look at differentiating exponentials and logarithms. You have touched upon this topic barely last year in year 12 when you learned to differentiate e to the power of x. You will know the derivative of e to the power of x is just e to the power of x. Okay, so we're going to extend from that point. We've got 3 bullet points in here, right? So the first bullet point is that if y equals e to the power of kx, then the derivative would be, we just pull down the k. We multiply by the coefficient of x. Ke to the power of kx. Now remember that e to the power itself doesn't change after differentiate. So e to the power of 5x, you get 5e to the power of 5x. So the e to the power of kx, the kx remains in the power. Okay. Next one, if y equals ln x, then this is a given. Okay, you will have to remember it. So then dy by dx, differentiate ln x will be 1 over x. Just an extra point extending from this. If y equals ln kx, then dy by dx will also equals to 1 over x. The k just disappears. Right? Now, well, y, okay, y, I'll put in the chain rule in here first. We'll go for it. We'll definitely go for it later. So, but next time when you read it, probably you'll understand a bit more later. So chain rule. So we'll leave some space in here. You can maybe write next time, y does ln kx equals 1 over x. But we're not covering it in this lesson. So just take it for given for now. So ln x or ln kx, the derivative is still 1 over x. The last bullet point, I'm going to leave it blank for now because we'll come back to this. So after the first example. So first example, show that the derivative of a to the power of x is a to the power of x ln a. So why is this different to e to the power of x? Well, because a is not e. A is a constant. So now we know to differentiate. So we know if we have, let's say, y equals e to the power of 5x, then we know the derivative is 5e to the power of 5x. So we can differentiate exponential functions with the e quite easily. Too many e words. Differentiate exponential expression easily with e in the base. Too many e's. But a is not e. So what can we do? We're going to cheat a little bit. We're going to, so I'm going, first of all, I'm going to let y equals a to the power of x. Now, if we can differentiate with the base e, then we will try to make it e under it. So we apply e on both sides. Well, actually, we apply e on the right side. So how do we do that? If I want an e in here, I cannot simply put e to the power of ax in here because that's making e out of nowhere. What I can do is, if I put e, and then I put ln in here, then that doesn't change the original, but that extra bit of different something in there. Because if we simplify, it still get the question. So technically we are correct, logically we're correct, mathematically as well. But how does that help us? Because then we can, using log rules, we can bring the x down. Okay, so we can bring the x in front of ln. So y equals e power of x ln a. Right? Now this proof is not required in the exam, so you don't have to remember it. But the result needs to be. But as a math teacher, I didn't need to show you where did it come from. I'm not that tough teacher tell you, okay, do this, do this, do this. Okay, this is the result. Okay, actually I did it in the beginning of lesson, didn't I? I told you ln kx is 1 over x. Well, yes. Well, anyway. But you, as a math teacher, you do need to understand that's the maths, where the maths come from. Right. So e to the power x ln a. Now this is the base of e, x times ln a. ln a is like the constant. It's like coefficient of x. So therefore, the dy by dx equals to ln a times e to the power of x ln a. Y. Okay, so I'll give you a bit of notes. Okay, so x ln a, okay, means ln a. That's ln a. ln a is the coefficient. Okay, so if I have to differentiate e to the power of 5x, I'll get 5e to the power of 5x. So 5 is the coefficient in here. So when we differentiate anything with the base e, we just have to multiply by the coefficient of x in the front. So x ln a is the coefficient, therefore you can multiply. So this ln a is like the 5 in this example. You bring it down, okay, multiply it, and the e, the power, stay the same. Okay, so now look at the left-hand side as well, come to the left-hand side. I've differentiated, therefore I put dy by dx on the left-hand side. Next, it's time to wrap it up. The right-hand side, I'm gonna put the x back in the power, so e to the power of ln a to the power of x. E and ln cancel out, so dy by dx equals ln a times a to the power of x. And we do tend to write ln ln expression at the back of the expression. So any ln terms we usually write at the end. So we write a to the power of x ln a. Right? It's the same as like trigonometry. If I tell you sine x times 5, okay, sine x times 5, or sine x times 5x, naturally we'll write as 5x sine x, wouldn't we? So like trigonometry or logarithms, they tend to have lower priority in terms of writing expression. We usually write at the end of it. Right, anyway, that's outside knowledge. So, and that's why, okay, so a to the power of x ln a. That brings us back to the notes, the third bullet point. If y equals a to the power of x, then dy by dx equals a to the power of x times ln a. And what about y equals a to the power of kx? Then dy by dx equals to a to the power of kx and ln a to the power of k. So if we have a to the power of kx, then the k just sticks with the a. You get another slightly different version is when you put on a k, which is k ln a. Right. So we'll just bring k down using log rules. Okay, right, we're going to use all of these together in the next example, in the next practice question. Right, the next one is a practice, but I'll go through a few of them with you first, and then maybe you can have a go on your own. Okay, so practice number 1. There are a lot of questions, so sorry, the spacing is not quite right, but just use the full width of the paper. So the derivative of 3 to the power of x. So I want you to compare with the notes. Which bullet point does it refer to? 3 to the power of x. That's not 3 is not e, it's not ln, so it's that one. 3 to the power of x, a is 3. So 3 to the power of x, 3. So therefore derivative is 3 to the power of x and then 3. So, oops. So that's the same as 3 to the power of x and 3. Okay. What about the derivative of x cubed? 3x squared. Okay. Now, by the way, if you're confident, okay, or if you would like to try all of them, you can have a go, pause the video and try all of them first before I give you the answer. Okay. Next one, ln 3x. Actually, that wouldn't be a bad idea. Why don't you, all of you pause the video? Okay, so one by one. So pause the video, have a go at this one. When you're ready for the answer, press play. Or if you're unsure, press play. So question by question, we'll do together. Okay, ln 3x. So let's go back. ln 3x. That's this one. ln kx. So ln 3x is the same as 1 over x without the 3. So it's just 1 over x. Okay. Next one. 3 to the power of 2x. Pause the video again. When you're ready, press play. I'm not going to say it many times. Just pause and play, 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 pause and play. 3 to the power of 2x. So 3 to the power of 2x, and then 3 to the power of 2. So 3 to the power of 2x, and then 3 to the power of 2, which I can rewrite as 3 to the power of 2x times 2, and then 3. Okay, both are 3 squared is not acceptable in here. This line could not be the final answer. You can either write 3 to the power of 2x, 2 ln 3, like what we did, or 3 to the power of 2x ln 9, 3 squared. Right? Very similarly, next one, that will be 2 to the power of 3x ln 2 cubed. That will be the same as 2 to the power of 3x ln 8, or 3 ln 2. We do not like to write ln 8 because it's like third form. When you have root, let's say root 27, we tend to write 3 root 3 instead. Why? Because if you've got another term with the root 3, that can be simplified. Okay, so whereas root 27 on its own, it's quite hard to see what terms can be simplified with root 27. Next one, 5 ln x. I'll let you think about this. It's like the same as 5 times ln x. So 5 is a coefficient, so it doesn't do anything. 5 times differentiate ln x, 1 over x. So this one is 5 over x. It's 5 over x. This is not the same as ln kx. Okay, that's one misconception a lot of students would have made. ln kx, the k has to be inside the ln, but this 5 is outside. So it's 5 times ln 1x, if you may. Okay, so it's 5 times differentiate ln x, 1 over x. Okay, it's 5 over x. Next one, there we go. E to the power of half x. The coefficients are half, so differentiate anything with power of e will multiply by the coefficient. So it's half e, the powers remain the same, half x. Okay. Next one, 5 ln 2x. Pause video, here we go. 5 times ln 2x, so 5 times, remember we have a differentiate, so differentiate ln 2x. Derivative of ln 2x is just 1 over x, because this ln kx, differentiate ln kx is 1 over x. You have to constantly refer back to these 3 bullet points. Okay, see which one it fits. And coupling with what you've learned in year 1 differentiation, like for example 5 times, you have to realize, you have to understand the 5, the coefficient has nothing to do with the derivative. 5 times 1 over x is 5 over x again. Again, why is ln kx? Why is the derivative ln kx the same as 1 over x? I'll explain in the next lesson about chain rule. Next one, d over dt of 9 to the power of t. D over dt. So you can see the variable changes in here, not a big deal, because this variable means what's your variable that you're differentiating against, or we call it variable with respect to. So t is a variable in here, so 9 to the power of t, so t is your basically your x. So do the same thing, 9 to the power of t. So which one is this? 9 to the power of t. A to the power of x, okay? A to the power of x. So a to the power of x, ln a. So 9 to the power of t, ln 9. Or if you want to, or if you've listened to what I just said about the ln 9, we don't like to write ln 9. A better one would be 2 ln 3, that's 3 squared. Okay, next one. 5 times 4 to the power of x. 5 times 4 to the power of x, differentiate that. 5 is just 5 times 4 to the power of x, a to the power of x. So 4 to the power of x, ln 4. So that's the same as 5 times 4 to the power of x. ln 4 could be written as 2 ln 2 because 4 is 2 squared. Then the 5 and the 2 can multiply, becomes 10 times 4x ln 2. It's a bit ugly, but that's what we usually write. If you don't like the times, we can write it 4 this. Okay. Last one. Ooh, very tricky. Differentiating x to the power 4. 4x cubed. Yeah, do not think too much. Okay, 4x cubed. So Are you, hopefully you're happier to apply on your own in the homework question. There are more questions. I mean, that's not the end of lesson. We've still got one more example to go through. But hopefully now you are more confident to apply these 3 bullet points. You've learned 3 new derivatives. Okay. Oh, there are 2 more examples. Actually, there's one more in here, and the next one more in there. Yeah. Example: find dy by dx. Okay, given that, so this time we look at composite functions. We look at functions more than 1 terms. So we can differentiate 1 by 1. That's the first one. We can differentiate e to the power 3x and differentiate 2 to the power 3x. Okay. Now, before we do this question, ask yourself a question again. What's the derivative of e to the power kx? What's the derivative of ln kx or ln x? What's the derivative of a to the power x or a to the power kx? Okay, so you should be able to ask yourself these questions. These are not given in the formula booklet. Okay, so dy by dx, example number 8. Without knowing these derivatives, okay, try to remember them first before you listen to the example, because it will help you massively to go through the example together with me. Differentiate e to the power 3x is 3e to the power 3x. Okay, we'll multiply by the coefficient of the x, 3 to the power 3x. 2 to the power 3x is the same as a to the power kx. That's the same as a to the power kx ln a to the power k, which is the same as 3e to the power 3x plus 2 to the power 3x times ln. Times not ln, sorry, 3 ln 2. Sorry, 3 ln 2 times 3 ln 2. The dot means times, so times 3 ln 2. That's final answer. Part B, ln x cubed. So ln x cubed. Well, we haven't learned anything about x cubed because all the x inside ln bracket is always power of 1. But we can use the log rules to bring the 3 in the front. So we can rewrite it as y equal 3 ln x plus ln 7x. That's one way, of course, to do it. There's another way, which you might have realized. Some of you might do differently. So here, differentiate 3 ln x. Differentiate now, dy by dx. Differentiate 3 ln x, 3 times derivative ln x, 1 over x, times 1 over x, plus ln kx, this ln kx, which is 1 over x again. So, by the way, this is ln kx. I hope you realize. This is 3 ln x, so it's different. 3 over x plus 1 over x. So derivative dy by dx equals to 4 over x. What's the other way, sir? Well, you mentioned you try to hold us for suspense. Well, you can use log rules, log A plus log B. I'll use a different way, so it's different plan. Part B, alternative solution. Log A plus log B is the same as log A B, log A times B. So y equals ln x cubed times 7x is 7x to the power 4. So we can bring the 4 in front, so y equals 4. Can I do that? Yeah, so 4 ln 7x. ln A plus ln B, ln AB. Yeah, and then differentiate that. That's the same as 4 times 1 over x. That's 4 over x. Yeah, that'll work. Okay. Right. Next one, part C. Okay, part C. When we differentiate a fraction with multiple terms in numerator, we can split it easily like butter. We split a fraction, part C. Part C, we split up the fraction first, so y equals 2 over e to the power of, 4e to the power of 3x minus 3e to the power of 7x over 4e to the power of 3x. So we can simplify the fractions first before we can differentiate. The first fraction, 2 and 4, so 1/2. So e to the power of 3x is not, it's not good to differentiate anything with x in denominator. So how do we write that? 1/2 e to the power of -3x. Next one, the coefficient 3/4 3/4 cannot be changed or cannot be simplified, so 3/4. E to the power of 7x over e to the power of 3x, you get the same as e to the power of 7x minus 3x. Subtract the power if the base is the same. 7x minus 3x is e to the power of 4x. Then we can differentiate. Then we're in a better place to differentiate. So differentiate e to the power of 3x, you multiply by the coefficient, which is -3. So -3 over 2, e to the power of -3x. Remember, when you differentiate e, the power doesn't change. Anything with e, the power doesn't change when you differentiate. Differentiate e to the power of 4x, you multiply the 4, so it'll be 3/4 times 4e to the power of 4x. The 3/4 times 4 will cancel out to be 3, so dy by dx equals -3 over 2, e to the power of -3x minus 3e to the power of 4x. That's the final answer. One more. A head scratcher. Literally. A child has head lice, and his parents treat using a special shampoo. The population P of head lice after T days can be modeled using P equals 460 times 3 to the power of -2t. How many variables in here? 2. P and a T. P stands for population of the head lice. T stands for days. Okay. Part A. Determine how many days have elapsed after the child has 20 head lice left. So how many days means variable of T. 20 head lice means P equals 20. So if you remember what I mentioned about modeling, it's all about equating the numbers given to you to the variable. So part A, when P equals 20, so P equals to 20 equals 460 times 3 to the power of -2t. So to work out value of T, we divide 460 over the left-hand side. So 1 over 23 equals 3 to the power of -2t. To work out value of T, or to make T a subject, we have to bring T down. The tool will be using ln. So we're ln on both sides. Because using ln, we can bring the -2t in the front. So ln 1 over 23 equals -2t ln 3. Then we'll continue to make T a subject. So divide ln through the left-hand side. So ln 1 over 23 divided by ln 3 equals -2t. Oh, actually, yeah. If I write a bit neater, that will be, yes, so ln. It doesn't matter how you write it because you've got to put it in the calculator all together anyway. And then to work out T, divide the whole thing by -2. So T equals to ln 1 over 23 over ln 3, and the whole thing divided by -2. Just put the whole thing in the calculator. You get T equals to 1.427, which is same as 1.43 days. Right? You know, actually that's not bad because modeling question about exponential. What is the initial number of head lice? How many head lice? Head lice, like mice, mouse. Is that plural for head lice? Ew, I don't know. Or maybe you can't count too many of them. Head lice. What is the initial amount of head lice in the head? Using the equation. When T is 0, okay, so when T is 0, 3 to the power of 0 is 1. So initial amount of head lice is 460. So this shampoo is actually quite good because initial amount of 460, after 1.43 days, that means after a day and a half, the head is only gone down to 20 head lice. From 460 to 20, wow, still 20. Imagine there's 20 crawlies in your hair. Yeah, yeah, and they're quite contagious as well. So if you've got head lice, do not go anywhere near people, okay? Especially me. Puppy, determine the rate of change. When you see the word rate of change is about differentiation. So we're going to do dp by dt. Okay, now we differentiate. Part A did not tell me to do anything about differentiation, so I did not do anything about differentiation. But part B, rate of change is differentiation. Differentiate. So differentiate. The 460 is just a constant. So 460 is a coefficient. So I do that. 3 to the power of -2t is the same as a to the power of kx. the derivative is a to the power of k times, a to the power of kx times ln a to the power of k. Oh, by the way, it's not x, it's t. It's t. So then, yeah, okay. So it's up to you whether you want to simplify it. I probably wouldn't. Oh, when t equals 3. So when t equals 3, just plug it in the calculator. So dp by dt equals 460 times 3 to the power of -2 times 3 times ln 3 to the power of -2. Just plug the whole thing in the calculator. I suggest you try it with me, okay? And you should see, you should get -1.39 in the calculator. So what is the unit? dp by dt, okay, dp by dt. P is the numerator. P means the headlights, the amount of headlights. P means days per days. That means the rate of change, is -1.39 lives per day. Okay, and that's the answer, right? So just very quickly, part B, rate of change means differentiation. And today you've learned quite a bit of differentiation knowledge, the 3 bullet points in here. The first two you're going to use quite a lot. The last one you don't usually use quite a lot, but when it comes up, you usually do forget. So 3 bullet points. Okay. So yeah, and next lesson we're going to learn the first rule of the 3.